what we're going to cover today is we're going to cover some Summatizing, part-whole relationships, recognise, identify and order numerals, assigning quantities to number and name, number sequences, partitioning within 5 and 10, halves and doubles, odd and even numbers. Now that might not make much sense to you just now, but hopefully after this session it'll make a lot of sense to you. So this session is going to set the scene for the series of the 8 sessions. So it's very important that we establish kind of the fundamentals here and really kind of start to see how the maths is made here. This session will involve some fun. You're going to enjoy this, trust me. And it's going to involve some, I see moments. So you're going to be sitting there, I get this now. So going to get some light bulbs clicking in the brain. The mission from all of us, Education Scotland, Making Maths Count, National Parent Forum, is to inspire everyone to enjoy maths more and understand maths better. Why count on us? Why I've been lucky enough to be selected to lead this? Well, we've got links with 25 out of 32 local authorities in Scotland in the last 2 years. We've worked with over 300 schools, and there are over 17,000 numeracy blueprints boards being used in Scottish schools. They're very active, very interactive and visual learning tool that pupils love using and teachers love teaching with. And all the strategies behind them really help develop that understanding as you'll see as we go on. So, enough of the intro, let's get into the real part of the maths. So this is what we call a 5 frame. And I'll tell you something, I like 5 frames. I like making 5 and I like using 5 as a reference point. Tibetizing, so that's that first word I mentioned earlier on. What is Tibetizing? So Tibetizing is the ability to recognise the number of objects without the need for one-to-one counting. And you'll see exactly what I mean right now. So I want you to tell me, how many dots do you see? So shout out the answer at home, and we all know that there are 2 dots. So that is you doing some Summatizing. You didn't have to count them. Ready for the next one? How many dots do you see now? Shout it out at home. Oh, some comments coming through already. Hold on, sorry, I didn't mean to do that there. Give me a second. I clicked the wrong button. Sorry, guys, just give me a second. So, right, so where are we? How many dots do you see now? Do you see that there are 3? And we might ask questions like, how do you see those dots? So can you see 1 + 1 + 1, or you can see 2 add 1? I'm just going to stop share a second because I don't know if I've got a wee slight technical hitch. Sorry, give me a second, I'd pushed the wrong button there. So I'm going to start the share again, sorry. That was that. Sorry, my fault there. So, next question. How many dots do you see? We know there's 3. So what we're doing right now is we're Summatizing. How many dots do you see now? You know the answer? Shout it out. The answer is 5. And what I'm going to say is we'll call this a fast 5. So I'm going to give that name a fast 5. These will call it a fast 5 because I want you to be able to look at that and tell me that it's 5 very, very quickly. This is a 10 frame. And I'll tell you something, I like 10 frames as well. I like making 10 and I like using 10 as a reference point. So after we build up all that knowledge using 5 frames, we can progress on to using a 10 frame. How many dots do you see now? Shout out the answer. The answer is 4. And I might ask you, how do you see it? How many dots do you see now? The answer is 6. How do you know there's 6? Hold on, back a second. You might see 3 on one side and 3 on the other side, or you might see it going up in 2s, or you might just know what 6 looks like. Ready for the next one? How many dots do you see now? The answer is 10. Good. Right, and I'm going to give that a special name. I'm going to call that a total 10. You don't have to call it a total 10. You might think of a different name for it, but I'm going to refer to it as a total 10. How many dots do you see now? The answer is 7. Good. How do you see it? So this is an important question because we can start to talk about how is the number 7 made. Well, you might see 4 on one side and 3 on the other side. or you might see 6 with an extra 1 down the bottom, or you might see it go up in 2s and so on. So that's an important question to ask when you're looking at dot images or looking at doing some subitizing here. How many dots do you see and how do you see it? You might just notice that it's 10 with 3 missing. How many dots do you see now? Shout out the answer. The answer is 7, and this time you might see it slightly differently. You might see it as a fast 5 and the extra 2. So therefore we get 7 that way. And it doesn't matter if I turn it on its side, it's still a fast 5 and an extra 2. And now we can do some subitizing without the 10 frames. So how many dots do you see now? The answer is, got it? 9. And again, you're maybe starting to spot this is 5 from the dice pattern, that's 4 from a dice pattern, so 5 and 4 is 9. You ready for the next one? How many dots do you see now? The answer is 6. And again, we might have to count 1 dot at a time, but eventually with enough practice, your brain will start to develop patterns and start to spot, look, I can see 3 and 3 in there, so the answer is 6. Again, that's subitizing. We're looking at that skill of, I don't have to count every single dot, I can kind of group things together and get the total amount that way. How many dots do you see now? Do you have the answer? Are you shouting out at home? I hope you are. The answer is 9. Good. And again, ask question, how do you notice 9? How do you see the dots grouping together? I see 3 plus 3 plus 3, but some people might see it differently. How many dots do you see now? Again, my brain kind of works like I can see 4, then I can see 3, so I know the total 7. And again, that's us, we're doing some subitizing. So subitizers, to recap, is the ability to recognize a number of objects without the need for one-to-one counting. Now, I'm quickly just going to check if I'm not going to read much of the chat messages, but we've got people sending me some key questions on my phone. So we don't have any key questions just now, so I will continue on. If you have any questions, put them in the chat box. If you're enjoying this, let us know. If you're on Twitter, get tweeting about this. We want to get as many people involved in this across Scotland as possible. So the hashtag is #NPFS Maths, so National Parent Forum Scotland Maths. Let's move on. Okay, so we're going to look at part-whole relationships. And again, that will become clear in a minute exactly what it is. Looking at how numbers can be formed, exploring the relationship between the whole number and its component parts, and it helps us make links with connections, links and connections with addition and subtraction. So here we go. So I might ask you, to draw 8 dots in a 10 frame. So you could draw 8 dots any way you like in the 10 frame, and I'm just going to show you most of the ways that pupils come up with. So we might choose to draw 8 dots like that. But the way I have done it, you can see, well, I've got this side, I've got a fast 5 here, and then I've got an extra 3 here. So I would like to draw a wee part-whole relationship picture here, or what I like to call a number bond picture. So I've got 8 dots, but what is it made up of, or what is its component parts? Well, I can see I've got one part that's 5 and another part that's 3. That is one way to make the number 8. And we can see there's connections and links that we can make. And we can say, well, 5 plus 3 equals 8, 3 plus 5 equals 8, 8 take away 3 equals 5, 8 take away 5 equals 3. So lots of connections we can make with that one picture. I wouldn't necessarily introduce this connections written down like that straight away. I would do lots of practice with the visuals, and you can obviously be doing this visually, but you can use a lot of concrete materials, which concrete materials is hands-on objects. So whether you've got counters or whether you've got objects in the house that are classroom that you can use to demonstrate this. Next one, you might choose to actually look at the number 8. Well, actually, I didn't see it as 5 and 3. I saw 6 dots at the top and 2 at the bottom. So therefore, another way to make the number 8 is 2 parts, or component parts are 6 and 2. We might choose to draw the 8 a different way altogether and say, well, actually, you could draw the 8 like 4 add 4. 4 on one side, 4 on the other side. And again, we can make connections and link. We can say things like 4 plus 4 equals 8, or double 4 equals 8. Or we can even say, well, half of 8 equals 4. So trying to build up a lot of kind of understanding of how numbers are made, how they're formed and what parts can come together to make numbers. Another way, just looking at that one picture, somebody might see it go up in twos. So we might see, well, actually, 8 is 2 plus 2 plus 2 plus 2. Or again, the connections are linked. You can talk about, well, 4 groups of 2 equals 8, or just go up in twos, 2, 4, 6, 8, and so on. So I'm just going to have a quick wee look in case anybody's got anything to say on the. Nope, no messages coming through. So again, if you've got any questions you want to ask, I'm getting them pinged to me on my phone, so I can certainly try and answer them. Hope you're enjoying it. Again, let us know. We want to make sure we get parents, children learning together, having fun, understanding maths. Right, what we're doing now. So recognise, identify and order numerals. So I am going to give you there will be links to this PowerPoint slide and any of the tasks that we do today on my website at the end. So this next task is quite a good one. So I have basically kind of a document which has all these things in front of you, and what I normally do is cut them out and I would then group them together. So we can see we've got lots of different things going on here, but what I would like to do is, okay, right, here's the number one. I want to match that up with the word one, and I want to match up with this one here. Then I've got the word 2, then I've got the name 2, and then I've got the numeral 2, and I want to link that up with the images with 2 dots. So eventually, if I cut these out and slide them about on the table and match them up, I'll be looking for something like that. So everything matches together. So that's a kind of good sorting activity to do. And again, that I will send a link or put a link to this task on my website for you to check out later. Also, I've just added in an extra one there, so it's important that you notice that you can rotate them around anyway. And I'll show you that in more example with the number 4 here. So here, this is 4 dots. That's a different way to do 4 dots. Other way, other way. So it doesn't matter how they're orientated. You can have lots of different ways to do the number 4. Even like this last one here as well. So another way we can do summatizing is we can, so I'm getting a message through there, but I'll answer that in a minute. Count the claps. So I'm going to clap and you're going to tell me how many times I have clapped. So a bit like the dot images, except this time we can obviously count things we cannot see as well. So I'm going to clap. Are you ready? And you're going to tell me how many claps I made. How many claps did I make? Do you know? The answer was 4. I'm ready for the next one. How many claps? Right, I'm going to break this one up a bit. I'm going to do it in 2 stages. Are you ready? Sorry, I'll start again. How many claps did I do that time? I hope you got the answer. The answer was 6 that time. So there's lots of things, and you can even be silly. You can even get your children to do dog noises or something. I'm not going to do it. I'm not going to do that. I don't want to look that silly. But you can do dog noises or something and to count how many times I'm not doing that. No way. Right, learn to count backwards and forwards while within 10 while developing the concept of before and after. So, count forwards from 10. So, can we see what that says down the bottom? We have the numeral 0 and we have the word 0. And we have no objects in here. Count up from 0, we go 0, 1, 2, 3. And at this point here, I just want to point out, we can see obviously in here I've got 1 dot, 1 object. In here I've got 2 dots or 2 objects. And here I've got 3 dots. But in the 0 box, there is no quantity assigned because that is 0 means we have nothing, we have 0. And it's important that children understand what 0 is. And I think they'll understand when they come and ask for a biscuit. They say there's no biscuits left. How many biscuits left? There's 0 biscuits left. You've ate them all. We can only go to Tesco once a week in lockdown. There's 0 biscuits left. Continuing on the counting, 4, 5, 6, 7, 8, 9, That was us counting forwards. We'll start again. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So counting forwards from 0. And it's nice to see that recognition with the numeral, with the word, and with the dot. So I can see here's number 4, there's the numeral 4, there's the word 4, and there is the 4 dots to correspond. And we can count backwards from 10. So let's try that then. So 10, 9, 8, join in at home, 7, 6, 5, 4, 3, 2, 1, 0. I've just got this image of lots of adults round about rooms just shouting out these numbers, and it's quite funny. So I hope you're enjoying it. So again, we can try this activity using the slides, but eventually we want to try and do it without the slides. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. I'm just going to quickly check, see if I've got any messages coming through. Doesn't look like it, so that's fine. We can continue on. It must be so clear. No questions are required. Okay, so we're going to look at some number word sequences. We're going to look at using before and after, or more than and less than. So we can see I have 3 dots here. If I put in 1 more, I can see that 1 more than 3 is 4. From that picture, I can also say, well, actually, 1 less than 4 is 3. So looking at this dot, if I take this red dot away or we hide it, we can say, well, 1 less than 4 is the 3 that we originally started with. Using the number line, we can say, right, well, what is 1 more than 3? So you can see I've highlighted 3. What is 1 more than 3? We can see the answer is 4. Then we can change the question. I can say, okay, what is 1 more than 4? Well, I can see that 1 more than 4 is 5. I can look at another question. Okay, what is 1 less than 2? So I've highlighted 2. I can say, what is 1 less than 2? And the answer is 1. And I can say, right, what is 1 less than 1? So again, I've highlighted 1. I'm going to say, what is 1 less than 1? 1 less than 1 is 0. Other questions we might pose or we might ask questions like, which number comes before 3? Which number comes after 3? So different terminology, but we're looking to develop the same kind of skills. Just a wee reminder, on Twitter, can you use the hashtag NPFS Maths? That stands for National Parent Forum Scotland Maths. We want to get this trending. We want to get as many people involved as possible. I think Joe Wicks had under 1 million views in his first week or 2. We might not get that far, but you never know. Scotland might be leading the way here. We might actually get other countries coming in and just watching what we are doing here. So please, let's get this trending on Twitter. If you're enjoying it, let us know, let the Twitter world know, let friends know, and let's get them involved as well. Quick wee check just to see if there's any messages. Nope, that's fine. Okay, here we go. Other activities you might want to try, counting on from 4 together. So don't always have to start at 0 or 1. So we might say, okay, let's count on 4 together. So 4, 5, 6, 7. We might count a sequence of 3 numbers and then get your child or a partner to say the next 3 numbers. Okay, I've got a question coming through there, so I'll answer it in a minute. So 5, 6, 7. So I might say 5, 6, 7, and I would want my child or my partner or the learner to say the next 3 numbers. If I say 5, 6, 7, my child would say 8, 9, 10. Okay, I've got a question coming in here, so I'm just going to answer this. So a question from Liz: would you always use a vertical number track for before and after? I would either that, you don't have to be a vertical track, Liz, but you might want to use a measuring tape because the measuring tape has got basically the numbers in their absolute position. So for early learners, understanding that before and after, then it's very important that they see the numbers in their absolute position. So a vertical number line is really good for that, or a horizontal measure tape, because we can see there's a clear progression. The one thing I wouldn't use is, sorry for the glare in the laptop there, but I wouldn't use 100 square when talking about this, because the 100 square is far too busy, and it's not a great tool for early number development. So I would always use either a vertical number line, or I would use a measuring tape, so you can see there's a clear order of the numbers there. Hope that answered your question, Liz. If you can let the guys in the chat box know, that'd be great. Keep the questions coming. We like questions, and we'll do our best to answer them. So again, Liz, if you could just let us know in the chat box if that answered your question, please. Other activities you can try, so we can copy and say short forward number sequences, start from different numbers. So I might go 6, 7, 8, and you repeat it, 6, 7, 8. Or we could say count together. I'll count one number, you say the next number. So I'll go 1, you say 2, I'll say 3, you say 4, 5, 6. So you can do alternate count and stuff like that. Or I might say 6, 7, 8, and you say 9. Or we might say, I'll say 3 numbers, then you say the next 3. So 1, 2, 3, 4, 5, 6. Or tell me the number after 17. What is the number after 17? What is the number after 17? 18. And we can obviously do all those activities backwards as well. Okay, well, I love the empty number line. So we've got the empty number line here. So Liz said, thank you. That was great. Good. So we've answered Liz's question. So brilliant, Liz. Thanks for getting back to us. Using the empty number line to estimate. So you can see here I have 0 at one end and 10 at the other end. And I'm going to put this blue arrow here. And I want you to tell me what number you think the blue arrow is representing. Do you have an answer? I hope you do. Okay, keep that answer in your head just now. Now I'm going to get the red arrow to point at another number. What number do you think that's pointing at? Get an answer. And finally, we've got a green arrow. What number do you think that green arrow's pointing at? And let's see if you got it right. Start roll. Sorry, I get carried away sometimes. 3, 5, and 9. Did you get those answers right? If you did, give yourself a wee pat in the back. Well done, guys. Okay, let's try another one. So again, we've got 0 and 10. Sorry. And this time we might just have some missing numbers in place. So what is the number missing here? The red question mark. What is the number missing here? The green question mark. So this one here is 3. This one here is 8. Next one. We don't need to go up in ones, we can go up in 2s. So here we've got 2, 4, 6, 8, 10. And again, I might hide a number. Say, what number is missing here? Do you know? Shout it out. The answer is 4. So good, well done if you got that. And we don't even have to start at 0. We can start wherever we want. So we can see we've got 7 and we've got 13. And we're going to play this arrow game again. So what number do you think that arrow is pointing to now? Do you have an answer? Let's see. Let's put another arrow on. What number do you think that arrow's pointing to? Do you have an answer? Let's see if you're correct. Do you have 10 and 12? If you did, well done, guys. Good. Let's move on then. So a wee bit of sequencing. So obviously we looked at the number line for sequencing, but we can just look at sequencing without the number line. And you can see here again, I've left out some numbers. So what I'd like you to do is say, what is this number here and what is that number there? What is that number there and what is that number there? So get your answers. And let me tell you, this must be 8. This must be 9. This must be 13. This must be 15. So we're going to look at, obviously we've been counting in ones a lot, so we can do counting in twos. So I might say, okay, I'm just going to quickly check, see if we get any more questions coming through. Nope, we're good to go. That's fine. Right, so skip counting in twos. So let's count in twos. So what I use for counting in twos is I like to use the big grid for this. So I would draw 2 dots, or use 2 counters, and say, okay, let's put 2 counters on there. How many do we have? We have 2. Let's put on another 2 counters. That takes me to 4 in total. Another 2 counters takes me to 6 in total. 8, 10, 12, 14. Next. 16. 18. Plenty. Good, so that's us counting in twos, and I'm using either visual clues here, the 2 dots coming up at a time, or we can use like, if you can see me in the corner here, I've got wee cubes here, so we can actually use cubes or physical counters to count in twos as well. And then I would like to link that to, so again, we could count twos in the vertical number line. So I'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And again, I like to see that pattern on a vertical number line or a horizontal number line. We can see we're hitting 1 and missing 1 and so on. Obviously, that's all my even numbers. Or if you feel confident and children understand the 100 square, you can show the pattern of counting in twos in the 100 square as well. But again, as I say, I prefer the vertical number line because it shows you numbers in their absolute position, and it develops the counting in twos develops a nice pattern on the 100 square though, as you can see. The reason I have red circles is just to highlight that's 10 groups of 2, 20 groups of 2, 30 groups of 2, 40 groups of 2, and 50 groups of 2, and so on, which if you look at this, 2, 4, 6, 8, 10, again, we see the 2, 4, 6, 8, the 10 part there as well. So let's look at skip counting 10, similar method. So I would use 10 counters, or if I've got 10 cubes or 10 multi-link rod cubes, so I can see that's a 10 rod, and I can go 10, other 10s, 20, 30, 40, 50, 60, 70, 80, 90, 100, so on. So that's a skip counted in 10s there. And again, I could demonstrate that on 100 square or number line. Skip counted in 5s. We've got 5 dots. 5, other 5 makes 10, 15. What's next? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Again, we can look at the pattern on the 100 square or on a number line. The reason I'm using the 100 square is because my number line only goes to 30. It's quite difficult to see it on the screen, or it gets far too small. Right, I'm going to stop here and just check. I think I've seen a message coming through there. Okay, that's fine. I don't think there's any particular questions for me today, so that's okay. So we're going to look at partitioning within 5 and then 10. Again, if you've got any questions, please pop them in the comment box. And again, hashtag NPFS Maths. Get it on Twitter, get us trending. Partitioning, what does partitioning mean? Partitioning basically means splitting a number into its component parts, and it's linked to the first kind of slides we're looking at earlier on. Like 8 is made of 5 and 3 and so on. So let's look at a wee bit more of this here. So how many blue dots are there? How many red dots are there? So what we're doing is we're partitioning 5 into 2 and 3 here. So Again, like to that slides we talked about earlier on, part whole relationship. Again, this is where I would then start to introduce these mathematical, basically, sentences here and say, look, well, let's start writing this formula down now. 2 plus 3 equals 5, 3 plus 2 equals 5, 5 take away 2 equals 3, 5 take away 3 equals 2. So earlier on when we're looking at the part whole at the very start, I wouldn't necessarily write these formulae down, but now once we've kind of established lots of practice of that, I would start to actually write down the mathematical sentences. Again, this is linked to our Summatizing earlier on that we did. How many blue dots? How many red dots? We can see it's 5, we can see it's 2, we can draw the number bond picture, we can again link it to Summatizing. But again, we can write down our mathematical sentences. 5 add 2 equals 7, 2 add 5 equals 7, 7 take away 5 equals 2, 7 take away 2 equals 5. Again, we're looking at partitioning 7 here. So there was one way to make 7. Here's another way to make 7. This time it's 4 and 3 make 7. And again, the number sentences to go with that. So you can see the partitioning links in quite well with the bar model, or the part whole relationship that we talked about at the start. Okay, the equal sign. We're going to talk about the equal sign. What does the equal sign mean? It means it's the same as. It means the same as something else. And I want to talk about its position is interchangeable. And I'll show you what I mean by that. And there can be more than one equal sign. So a lot of time we think in maths, we think the equal sign basically is at the end and it gets us the answer, but that is not the case. So we can have the equal sign at the start. So 8 is equal to 6 plus 2. 8 is equal to 5 plus 3. 8 is also equal to 10 take away 2. 2 plus 8 equal to, what are you thinking? 2 plus 8 is equal to 10? Well, we don't have to write 10, we can write something else. It's equal to 7 plus 3. So we don't always have to have the exact answer. So the equal sign just means these things are the same as each other, equal to each other. So 2 plus 8 is equal to 7 plus 3. We can have more than one equal sign. So 8 is equal to 6 plus 2. That's equal to 5 plus 3. It's equal to 10 take away 2. It's equal to double of 4. The equal sign just doesn't mean you say that this is us in maths, we're going to get the answer. It means it's equal to something else. A good activity to do with involving equal sign is kind of filling in the missing number. So 5 plus something equals 7. And again, I would like to kind of show this visually. So 5 plus what equals 7. So I put my 5 dots. I realise I want to get up to 7. The missing number must be 8 equals 9 take away something. So again, this is quite a tough concept, but if we use a visual clue, it really helps us. So people typing in answers here, are they? I hope they are. So we've got 8 dots, but that's equal to 9 take away something. Well, you can see I've got 9 dots over this side. I want to get it equal to that side. So what do I need to do? I need to cross out that dot or take it away to make it the same. So 8 is equal to 9 subtract 1. I hope you got that right, guys. 6 is equal to double of something. Well, if I look at 6, what is that equal to the double of? It's equal to the double of 3. Did you get that right? I hope so. It can even involve two kind of mathematical kind of statements here. So 4 plus something equals 9 subtract 3. So I'm going to start with my 4, but that's equal to 9 subtract 3. So there's my 9 dots. I need to subtract 3. So how do I get these two equal to each other? I need to add on some dots here. How many dots did I have to add on to 4 to get it equal to 9 take away 3? It was 2. Who got that one before me? Well done if you got that before me, because it's a tricky wee concept that, but I think the picture really helps build that up. I'll just show you that again. So again, we have the 4 plus something equals 9 take away 3. So I'm trying to make these equal to each other. So I subtract my 3, I add on the relevant number, and make them equal, and I can see it's 2. And we obviously don't need to have a visual clue every single time. We're hoping that we can get to the point where we can answer this without using the visual clues all the time. But if the learners need it and are building confidence from it, then use the visual clues until they're ready to step away. So 4 plus 3 is 7. 9 take away what gets me to 7? It must be 2. 4 equals half of what? 4 is equal to the half of... Can't hear anything. 4 is equal to half of 8. And let's just look at a bit of halving and doubling now. Quick recheck of the meshes. No meshes so far for me, so that's fine. Halves and doubles. So again, a really important connection in maths to understand. So I'm going to have a wee number machine here that doubles whatever I put in. So I'm putting in the image of 4 dots and the number 4. If I double that, I get 8 out. So what can I say there? Well, I can say, so double 4 is 8. I can also say, and 4 is half of 8. So from that wee picture, we can say double 4 is 8, and 4 is half of 8. Okay, next question. Again, I just want to link that to the summatizing that we did at the start. So I don't know if anybody heard that. There's something that must be one of the kids' toys started singing a wee song there or something that put me off slightly. So sorry about that. Okay, so we're starting with the double machine and we've got 9 dots. I'm going to double that. If I double that, we can see I get 9 plus 9, which is 18. And again, that's linked to almost 10 plus 10, which would be 20, but there's 2 spaces missing. So again, we can make these statements. So double 9 is 18, 9 is half of 18. If I've got, again, just we link to the summatizing, and we can see the importance of this summatizing right throughout. And this, again, we'll talk about summatizing in the following sessions as well. And this time we've got a half machine. So if I've got 6 and then I put it into the half machine, what do I get out? I get 3. And we can say, so half of 6 is 3, and 6 is double of 3. Let's see. Why are doubles important? Well, if you were going to look at something like 7 plus 8, and you know what double 7 is, you can think, well, 7 plus 8, it's really just 7 plus an extra 1. And I know double 7 is 14, and I know 14 add 1 is 15. So your double knowledge really helps you out with a lot of addition problems like that one there. Going to talk about odd and even numbers now. So I'm sorry, I'm just going to quickly check just to make sure we've got no more questions. No more questions. Come on, guys, I like questions. So if you've got a wee question, put it in the comment box for me. I know the team are working in the background trying to answer ones that come in, but any for me, please send them in. So odd numbers. So sorry, odd and even numbers. So what do we have here? We have 1, which is odd, 2 even, 3 odd, 4 even, 5 odd. And I might want to stop here and ask, what do you notice and what do you wonder? So what do you notice about the odd and even numbers here? Is there a visual clue or is there a visual difference? I'll go into the next screen and say, okay, here's 6, 7, 8, 9, 10. What do you notice? What do you wonder? Is there a visual clue, the difference between the odd and the even numbers? And you can see the way I purposely displayed the dots, that all the even numbers, there's no space missing. They've all got a pattern on each dot. Whereas here, 9, 7, I've got this extra wee dot kind of on its own. So I get a nice wee pattern or a nice visual clue to look at the difference between odd and even numbers. And another way we can look at the difference between odd and even numbers is if we write the numbers in the 10 frames exactly the way I've written them here. So you can see I've written the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 20. But I've written them purposely like that so that we can say, like, actually, those numbers there are our even numbers. So 10:50, and we've pretty much finished the first session. So I'm just going to kind of recap here. So we did some summatizing. Hopefully you're clear what that is. The part-whole relationships was basically how we form numbers. So 5 add 3 is 8. And that kind of linked to the partitioning as well. Recognize, identifying order numbers. So talking about counting forwards and backwards and looking at before and after. Number sequences. Again, we talked about counting 1, 2, 3. You say 4, 5, 6, and so on. Also number sequences with numbers missing or going up in 2s and so on. Halves and doubles we mentioned, we just covered that there, and odd and even numbers. So the slides and resources can be found on my website, which is www.countonus.org.uk/learning together.